Hello everyone. In this video, I'll discuss about the capacitance of the spherical capacitor. Now, in the last video, I have discussed about the capacitance of parallel plate capacitor, and you know that for parallel plate capacitor, if air is there or vacuum is there in between the plates, then your capacitance is epsilon naught A by D. D is the distance between the two plates. And if a dielectric is inserted in between the plates having dielectric constant K, then the capacitance, let's say this is C0, then the capacitance is K times epsilon naught A by D. Or you can say the new capacitance is your K times C0. So this is what we have discussed in the previous videos. And now in this video, we'll discuss the capacitance. We'll calculate the capacitance of spherical capacitor. Now, like parallel plate capacitor, where two plates were there, in case of spherical capacitor, here two spheres will be there, concentric spheres will be there, metallic sphere or the conducting spheres, and the inner sphere may be a solid sphere or hollow sphere, but the outer sphere is a hollow sphere one, and in between there should be gap. So some insulating stand or something may be there so to hold it. Let's say the inner sphere having positively charged, it's positively charged, and the charge is, let's say, it's plus Q. The outer sphere is negatively charged, equal amount, and it's, let's say, minus Q amount of charge is there. Now let's say the inner sphere having radius R1, outer sphere having radius R2, and as the inner sphere is positive, so the electric field will be in outward direction. This will be the electric field direction. Now let's consider a hypothetical surface sphere, Gaussian sphere, and it is at a distance smaller from the center. And let's say this is point P. So according to Gauss law, the charge enclosed by the surface will be the flux. Charge enclosed by epsilon naught is the flux. And also we know that the flux is equal to the E dot your ds, that is your surface. So here your E is, your surface is 4 pi r square, and E is 1 by 4 pi epsilon naught, and charge is Q by R. So, okay, so here, instead of writing this E, I can write directly like this, that I'll keep it as E because I want to calculate E. So E ds is my 4 pi r square. And this flux from Gauss law, we know that your flux is equal to epsilon naught by your Q by epsilon naught, which is equal to your E4 pi r square. And from here you can calculate, this is flux and this is charge Q. This is the difference. So E equal to, you can say, Q upon 4 pi epsilon naught r square. So electric field, if a sphere is there, right, and we know that the enclosed by a Gaussian surface, then the electric field at a distance r will be just like a point charge Q by r square, 1 by 4 pi epsilon naught Q by r square. That is why that is what we know, right? Now if we'll take another Gaussian surface outside it, so it will be 0 because plus Q minus Q net charge is 0. So there will be no point of discussing R outside the sphere. So we'll discuss R in between the plates. So outside the plate, it will be outside the plate, E will be 0. And also inside the plate, if there is no charge, the charge is only on the surface. So inside the small sphere also electric field will be 0. That's why we have only the electric field in between the two plates. Like the parallel plate capacitor also, the field in the left side is also 0. The field in the right side is also 0. Only the field exists in between the plates, that your E equal to sigma by epsilon naught. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught, sigma by epsilon naught. So here also the field exists only between two plates. Outside the sphere and or inside the small sphere, the electric field is not, there is no electric field, or you can say electric field is 0. Now we can find out the potential, because our target is to calculate the capacitance. So C is equal to basically Q by V. So here we are interested to find out the V, potential difference. So the potential difference is equal to, let's say, the inner sphere having the potential, higher potential, V plus, minus the outer sphere having potential, let's say V minus, which we can write minus of E dr or E dot dr. Negative sign is because E and d are opposite in direction. Dr we are going against the field, so that the energy will be stored, and E is outward, dr is opposite direction, so a negative sign we have introduced. And the integration we are going, as we are storing the potential energy or potential, so we are going opposite direction. That's why the dr will be r2 to r1. R2 is the radius of the outer sphere and R1 is the radius of inner sphere, right? Now we'll just simply integrate. We'll put the value of Q from here. We'll use here, so that it will become Q by 4 pi epsilon naught R square dr integration R2 to R1. Now you see Q minus Q by 4 pi epsilon naught will come outside. Only we'll find out the integration of 1 upon R square dr, that is R2 to R1. Now integration of 1 upon R square is minus 1 upon R, right? You know that you can use the formula 1 upon x square dx integration. If we say, it will be x to the power minus 2 dx basically. So you can use the formula x to the power n formula, x to the power n plus 1 by n plus 1. So it will be basically x to the power minus 2 plus 1, that will be minus 1 by minus 1, or you can say this is minus 1 upon x plus c, right? If it is indefinite, if definite, it will be 1 by x and the upper limit, lower limit will be there. So 1 by R square dr, similarly you can write that the V is equal to, and minus minus plus will be there, so Q by 4 pi epsilon naught, and this is minus 1 upon R, so minus minus already have taken plus, so what, this is 1 by R, R2 to R1. Now I'll put the limits, so it will be my Q by 4 pi epsilon naught 1 by R1 minus 1 by R2. Now if I want to write, I'll simplify it, so it will be Q by 4 pi epsilon naught LCM R1 R2, and this is R2 minus R1. So this is my V, this is my potential difference, that is V. Now I'm interested to calculate the capacitance. So how can I do that? C is equal to Q upon V, and this is your B is in the denominator, so these terms will go up. So I can write this as Q 4 pi epsilon naught R1 R2, in the denominator it will be Q by R2 minus R1. Now Q gets cancelled, so finally our C comes up, capacitance comes up as, your C comes up as 4 pi epsilon naught R1 R2 divided by R2 minus R1. R2 is the radius of the outer sphere, R1 is the radius of inner sphere. So 4 pi epsilon naught R1 R2 by R2 minus R2. This is the capacitance for spherical capacitor, right? I hope the derivation is clear. If you find any difficulties or any steps you are not clearly, you have not understood, you can write in the comment box, so that if possible I can make another video clarifying your doubts. Thank you for watching. See you in another video.